My name is Ilyas, and I want to tell you about the father of quantum physics, Erwin Schrödinger.
Erwin Rudolf Joseph Alexander Schrödinger, or sometimes called as Erwin Schrödinger, was born on 12 August 1887. He was a Nobel Prize-winning Austrian-Irish physicist who developed a number of fundamental results in quantum theory, the Schrödinger equation. The Schrödinger equation provides a way to calculate the wave function of a system and how it changes dynamically in time. One time on the night in the cafe, someone was asking to Schrödinger, "Is your cat still okay?" Schrödinger replied with a little smile. "That is just an illustration, or maybe a paradox." And the man said again, "You know, Schrödinger cat has been a famous discovery in quantum physics." And Schrödinger answered again, "I was just inspired from Einstein in 1935. There is a hypothetical cat that may be simultaneously both alive and dead, a state known as superposition quantum, or quantum superposition." And the man said again, an illustration that often used in many theoretical discussion about interpretation of quantum mechanics." And Schrödinger said again, "Are you sure? I thought it'd just be a ridiculous thought." Long time before that, in 1935, Schrödinger was drinking a cup of coffee at his house in Austria, and then asked his wife, "Honey, did you know the latest news?" And she answered, "Yes, Erwin. Einstein, Podolsky, and Rosen have made an article, or known as EPR article." Schrödinger said again, "Oh yeah? What's the article about?" And his wife answered, "I'm not sure, but I think this article was written about word behavior in quantum superposition." And again, I still didn't get it. His wife looked confused about it. That Schrödinger just laughed a little and read a little to this article introduction and said, "No problem, this is just a quantum system, such as atoms or photons, can exist as a combination of some conditions that correspond to different possible results." And his wife said, "Yeah, whatever you said, I still didn't get it. By the way, will you explore this theory or maybe contribute with another experiment?" And Schrödinger said again, "I think I will. I will ask and discuss it with Einstein." But he and Einstein exchanged letters about Einstein's EPR article. A few days later, the letter came to his house, and then his wife took it and gave it to Schrödinger. "This is I bring for you a letter from US." "From whom?" said his wife. "Oh, this must be from Einstein," said Schrödinger. "Seriously? Let's check it out," said his wife, and Schrödinger opened the letter quickly. After a few seconds, his wife asked, "Is there written a drum that contains gunpowder? Are you both writing about business of weapons?" Erwin just laughed a little and said, "No, this is just an illustration about quantum superposition." And his wife said, Yeah, maybe I got it." The next day, in the morning, Schrödinger was writing on his working table, and then his wife came and said, "Will you reply the letter from Einstein?" And Schrödinger answered, "Of course. I'm writing the reply. I will give another interpretation to make it easier." And his wife said, "That is why you write cat in your letter." This letter, Schrödinger wrote, Even someone can set up ridiculous cases. The cat is connected up in a steel chamber with a Geiger counter and a tiny bit of radioactive substance. In an hour, one of the atom decays, but also with equal probability the atom doesn't decay. If it happens, the counter tube is charged and releases a hammer that shatters a small flash of hydrocyanic acid. If someone has left this entire system to itself for an hour, the people would say the cat still lives if there is no atom doesn't decay. But the first atomic decays would have poisoned the cat. So the C function of the entire system will express by having in it the living and dead cat mixed or smeared out with equal parts. Schrödinger didn't wish to promote his idea about dead and alive cat as a serious possibility, but he wanted the example to illustrate the absurdity of the existing view of quantum mechanics. Who knows, his idea has been used in many illustrations about quantum mechanics behavior.